Hey guys, welcome to lesson 2, part 1. We're going to talk about applying properties of rational exponents. And back in earlier units of Algebra 2, you talked about properties of exponents. So the part of it is not going to be anything new. It's just applying the rational part of it. So this property, again, like all of these properties you have seen before, but I'm going to give you an example of what it's going to look like in the form of rational exponents. So rational exponent, that is a fractional exponent. So let's call a to the 1/2 times a to the 3/2 power. So the rule is you add the exponents together, and so that's what we're going to do. So we're going to take 1/2 plus 3/2 is 4/2, which is a squared. Okay, let's do another one. So I'm going to call this a to the 1/2 power squared. And so when you raise a power to a power, you multiply. So I'm multiplying these two things. So half of 2 is 1. So it's just a to the first power, or a. So what if we're having more than one thing in the parentheses that we're taking to that power? So the rule is here is we're just going to distribute that power. So I have a to the 1/2 power and b to the 1/2 power. This next one, when you're dealing with negative exponents, remember whether it's in the numerator or the denominator, it's not happy where it is, so you need to change places. So this is like a over 1, so we're going to do this 1 over a to the 1/2 power. So notice that this exponent now is positive because it's where it should be. Okay, this next one, let's do b to the 3/2 power and b to the 1/2 power. So the rule is with division or fraction, you're going to subtract the exponents. So this is the same thing as saying b to the 3/2 power minus 1/2 power. So 3/2 minus 1/2 is 2/2, or just b to the first, or b. Okay, and finally the last one. So we're going to take a over b and take it to the 1/2 power. So this is very similar to this one that we did up here. Just like we did up here, we're going to distribute, so a to the 1/2 power over b to the 1/2 power. And so from here on out, we're going to use all of these properties. So again, you've used these properties before, just going to look a little bit different with the rational exponents. Okay, so I'm going to go through and talk about each one of these, and let's kind of refer back. So the first thing I'm going to ask myself on all these is like, what do I do? What's the rule? So the rule here is I'm going to add the exponents. A big mistake that students make a lot is they want to multiply these together. The base stays the same. So it's 3 to the 9/3 power. 9 over 3 is 3 to the 3rd power, and if you want to take it to 27, that's great. Okay, the next one, we are raising a power to a power, so we're going to multiply. So let's see, 64, and let's just say 4/3 times 1/4. Well, these cancel out, and I'm left with 1/3. So it's going to be 64 to the 1/3 power. So 64 to the 1/3 power is, think about what we've talked about before, it's rewritten, it can be rewritten like that, which is the same thing as 4. Okay, same thing with this, same rule. So notice the similarities there. So I'm going to take 8 times 3/2. So this becomes a to the 12th power. Again, same rule. So we have 3/2 times -2. I'll call it -2 over 1. So I have -3. So I have p to the -3 power. So this brings in another, that negative exponent rule. So this is the same thing as 1 over p to the 3rd. Okay, this one, look at this. So we're just going to drop that coefficient because it's being multiplied. All of these three things are being multiplied together. So we're just combining the like terms here and here. So when you multiply the b's, you add their exponents. So I have 1/2 plus 4/3. If you use a calculator, you know how to work it. Use your calculator to do it by hand. We have to find a common denominator. So 3, 6, 6 is our denominator, plus 8, 6. So we have 11, 6. So 3b to the 11 6th power. And so finally, this one, I'm going to multiply the coefficients. So I have 2 times 4 is 8 times 4, which is 32. And then for these, again, they're being multiplied, so I'm going to add their exponents. So I have 2 plus 3 halves minus 4. So let's go ahead and do these two. So I have 2 plus 3 halves. That's the same thing as saying 4 halves plus 3 halves, which is 7 halves. So 7 halves minus 4. This is the same thing as saying 7 halves minus 8 halves, which is negative 1 half. So I have m to the negative 1 half power. And again, I need to make that positive. So I have 32 over m to the 1 half power, or I can rewrite it as 32 over the square root of m. Okay, now we are going to kind of switch gears a little bit, and we're going to write the expression in simplest form. So we are going to find perfect squares in this case, or perfect cubes in this case, or perfect fourths in this case. So think about that list that you got in lesson 1. It might help to look at that list. So let's start here. So 45. So look at your list, your square root list. And think about a factor of 45 that is a perfect square. So 9 is a perfect square, and 9 times 5 is 45. So I'm going to look at this as the square root of 9 times the square root of 5. So the square root of 9 is 3. So my answer is 3 square root of 5. So we're going to do the same thing over here, except now I'm not going to look at perfect squares. I'm going to look at perfect cubes. So I want you to find the biggest perfect cube that you can find that is a factor of 375. So you should see that 125 times 3 is 375, and the cubed root of 125 is 5. So let's see how this works. So the cubed root of 125 times the cubed root of 3, and this becomes 5. So my answer is 5 cubed root of 3. Okay, this one, same thing. So we're going to look at that fourth list, a perfect fourth, and see the biggest factor of 64 that is a perfect fourth. So you should see that 16 times 4 is 64, and 16 is a perfect fourth because the fourth root of 16 is 2. So my answer is 2 fourth root of 4. Okay, so we're going to simplify in a little different way this time. So we have kind of two different things going on. So we have 2 fourths. So if I just had that, that would be 1 half. So I'm not too concerned about that. But here I have this division problem. So remember, I'm going to remind you up here in this one, when we have a division problem, we are going to subtract the exponents. So I have x to the 7/4 minus 4/3. So go ahead and do the math and see what that ends up being. So it ends up being negative 37/12. So I'm going to keep, like when you subtract, you're always going to keep it on the top and then kind of reevaluate where it needs to go. So because this is a negative, it's going to go down here. So my final answer is 1 over 2x to the 37 over 12 power. Okay, and then this is another one that we have talked about earlier. So when you have, let's go up here. where is it? Right here. So when you have different variables, you are inside the parentheses, you are going to distribute the exponent on the outside. So that's where we're coming from here. Right here. Okay, so we're going to distribute that 2 to each thing. To each thing that we see, we're going to distribute that 2. So when I raise a power to a power, I'm going to multiply. So let's kind of erase it. So I have -1 times 2, so a to the -2 power. I have 1/3 times 2, so b to the 2/3 power. I have -4/3 times 2 is a to the -8/3 power. And b to the second times 2 is b to the 4th power. Now, you could have taken a different approach and like combined like terms inside, then distributed the 2. That's totally up to you. You're going to do it eventually either way. So now what we're going to do is we're going to multiply these together. So remember, when we multiply, we add their exponents. So I'm taking -2 plus -8/3. So let's figure out what -2 plus -8/3 is. And I get -14/3. And I'm going to do the same thing with my b. So I'm going to say b to the 2/3 plus 4. So go ahead and combine like terms there and see what you get. And I get the same thing, except it's +14/3. So the last thing that I need to kind of be aware of is this guy is negative. So I'm going to keep the b on top because he's okay where he is. And then over a to the 14/3. So it looks like that. Okay, so this is our last kind of thing that we're going to do to simplify. So it is very similar to what we did up here. So we're going to start off with the numbers, the same thing as the same way that we did up here. So what is the biggest perfect cube that is hiding in 16? And so I know that 8 times 2 is 16, and the cubed root of 8 is 2. Okay, so then I'm going to take each one of these and say, okay, well, what can I take the cubed root of? Well, I can take the cubed root of that. That is 2. So I can't take the cubed root of that. I can't take the cubed root of that, and I can't take the cubed root of that. So my final answer is 2 cubed root of 2xy. Okay, so let's do this one, same thing. So I know I've got this -16. So I'm going to break that up into the cubed root. So, or the perfect cube, just like I did over here. So we knew over here that 8 times 2 is 16. So I'm going to say -8 this time times 2. And then I have an a to the 3rd, and I have a b to the 8th. So let's go ahead and talk about the numbers. So this is going to come out the cubed root of negative. So remember, odd roots are totally okay. So it's going to come out as a -2. This guy can't do anything with. Okay, when you get to variables with exponents, think division. So we've talked about this before. So I'm looking at this as a to the 3/3 power. This is my exponent that's on top. This is my root that's on bottom. Okay, so what's going to happen is I can take the cubed root of that. That is just going to come out, 3/3 is 1, so it's just going to come out as an a. So let's talk about this one. So this is b to the 8/3 power. So think about this. I always think about it as turning it into a mixed number. So 8/3 is the same thing as 2 and 2/3. So I know that a b squared is going to come out of it. And here's another way to look at this. So if I have 8 b's, every group of 3 is going to come out as a b, just like we saw here. So this is going to come out as a b, this is going to come out as a b, and then I'm going to have 2 b's left over. So this is the thought process that I go through. I go ahead and put a b squared down here. That's what's going to come out. B times b is b squared. And then I always put like what's left over up there. So my answer on the outside right here, I'm going to come down. I'm not going to worry about this right now, is negative 2ab squared. And then the cubed root, and let's see what's left over. So we took that out. We've got a 2 left over. We took that out. And then we've got a b squared left over. And that is it. Okay, let's do the same thing here. So I'm looking for a perfect cube that is a factor of 56. So 8, and I know that 8 times 7 is 56. I have an x to the 5th and a y. So let's see how this happens again. So the cubed root of 8 is 2. So that comes out. This stays inside. 3 goes into 5 one time. So I'm going to have one x that comes out with 2 x's left over. And then 3 goes into y. That cannot come out. So that's going to stay inside as well. So my answer is 2x. Then I have the cubed root of 7x squared y. Okay, and let's do this last one here. So again, I'm going to go through that same process, finding the perfect fourth now of 128. So 16 times 8 is 128. And so the fourth root of 16 is 2. So that's going to come out as a 2. That 8 has to stay inside. Let's see, 4 goes into 7 one time. So x to the first is going to come out. And I'm going to have 3 left over because 4 goes into 7 one time. And then remainder 3. So that kind of look at it like that. Okay, 4 goes into 9 two times. So I'm going to have a y squared, and I'm going to have 1 left over. Okay, so my answer is 2x y squared times the fourth root of, let's see what's left over, 8 x to the third y to the first, or just y. Okay, so this is the last one. We are going to get into this into day 2. So I'll just kind of show my steps and we'll go more into it in the next video. Okay, so I've distributed the 4, negative 28 over 3. That is, guys, this should have been 28. I'm sorry, this is negative 7 over 4. That was a typo. So this is 28 over 4. Negative 28 over 4, which is negative 7. So let's kind of clean that up a bit. So I have x squared, y to the negative 8, and then y to the 4th, x to the negative 7. And so I'm going to look at this as 2 minus negative 7, and then y to the negative 8 minus 4 power. So I have 2 plus 7, so I have x to the 9th, and then I have y to the negative 12th power. So I just need to make that one positive, so x to the 9th over y to the 12th, and we are done.